I'm Dr. T, and welcome to my office. Today I'd like to talk a bit about the origin of astronomy, chemistry, and physics. So astronomy starts out and is arguably one of the oldest of our sciences, or the oldest originating science. Actually, frankly, oldest science. So of course with astronomy, as humans, we look up into the sky and like, what's that? And human curiosity is something that should never be discounted. There's a lot of talk, and I'm going to go a lot into the practicality and the practical needs of a lot of things. But seriously, just going, what's that? Is a huge thing. And it should never be discounted that every single human is curious, at least to some degree. We should never think, oh, these people aren't curious, or these... No, everyone's looked up and gone, what's that? And to answer that question really begins astronomy. And of course, there is practical benefits to astronomy. The Earth goes around the sun. That's why we have seasons. Seasons, if you are anywhere but like right on the equator, are a major deal for you. And even if you are on the equator, you can have rainy season and dry season, that kind of stuff. It's not your normal four, but it's still seasons. And this is going to affect you. You need to know when you put the seeds in the ground, or when whatever critter is going to be walking by, so you know what you need to do. Do you need to get up and move to some other place? If so, when do you do it? And one of the goals of astronomy is going to be chronology, or understanding time and timekeeping. Not necessarily on the second-by-second basis, although, hey, sundial, but also on a day-by-day or season-by-season basis. If we look at ancient sites, we quite often see caves that happen to be aligned to when the cave is illuminated by the rising or setting sun at certain times of year. And hey, lo and behold, it looks like that area. It's got paintings on it. It says, hey, these critters are roaming around. And it's pretty obvious that these natural formations were being used for astronomy. The same for a lot of megalithic sites. Things like Stonehenge, Mayan pyramids and whatnot. These definitely have alignments that look to be more than just coincidental with things like the equinoxes, etc., which means that they may very well have had timekeeping purposes, whether it be purely for ritualistic purposes or for very practical, when do I plant, when do I do this, when do I do that, purposes. Once society starts building up sea travel, of course, astronomy becomes another key focus, and that is for cartography. You need to figure out, where am I? I don't know. It's just water. So, hey, if I'm in a big body of water, how do I figure out where I'm at? My only point of reference is going to be the sky. I can't look out to the land because I can't see land because I'm in the middle of nowhere. So then astronomy gets this very useful tool of looking at where the stars are, therefore determining where I'm at. Latitude is a whole lot easier to determine than longitude. So it becomes really kind of locked in very early. You start seeing ancient tools to measure the angle of the sun and stars, and using those to figure out where you're at geographically. So yeah, now of course with the sun, with the sky's ability to predict the seasons, and yeah, what's the next step? We can predict the season, we can predict what the buffalo are going to do, maybe we can predict what's going to be a good year and a bad year, and we get astrology, which through most of human history was actually the big one, the important one, and astronomy was the little brother that was kind of dorky and nerdy. Obviously astrology, the stars do not determine your fates. Sorry. They help you know where on Earth's orbit you are, and that is important to you, but they don't determine, who the best lover is going to be. I'm sorry. Boy, it would be nice if they could. But yeah, so those disciplines, understanding the stars to know where you're at, how they're moving, how to make tables that would help you make time, because we start out, hey, here's what we're looking at. Hey, some of these things move. There's the wandering stars, the planets. How do we predict where they're located? And that then starts building and development of what's going on. We start getting this development of techne, or technology. Things like the telescope, we can start looking at them more, and we start understanding what's going on in our sky. The next one I want to talk about is that of chemistry. I'm a chemist, so of course I am very biased towards this one. Chemistry starts out as several very distinct disciplines that merge together, all very for nice practical purposes. Of course, the classic is alchemy, and alchemy gets a bit of a bad rap, partially because, like astronomy and astrology, it kind of went cuckoo, but it did so in an understandable way. So if you look at alchemy, the core of it is actually what we would have the modern discipline of separation science, trying to figure out ways to purify, separate, and figure out what you have. If you imagine a bottle of wine, you could take the bottle of wine, pour it in a vessel, heat it, collect the vapors, and now those vapors would be far more intoxicating than the same amount of wine. In fact, you could take the intoxication from an entire bottle of wine and put it into a small cup. You're taking the essence, the important part of the wine out. You're distilling out the alcohol. Alternatively, you could take a whole bunch of flowers, probably dump some wine in here just to help it out, boil that, distill that off, and you can get something that a tiny vial smells the same as the whole bouquet of flowers. Or has a medicinal function that a large amount, imagine taking, say, some poppy and then extracting it, and you could have a small vial of juice that would have a very potent effect. It would be opium. This is useful. You can make useful things with this. Of course, in China, we get the development of black gunpowder. Well, by that point, black powder, guns hadn't been invented yet. Adding to the work of the alchemists was also the work of the apothecaries. Apothecaries are essentially the precursor to the pharmacist. In fact, in certain countries, if you go to the pharmacy, it's actually called the apothecary. The goal here would be to take natural substances, mostly herbs of various types, and form medicinal compounds from them, thus using that to treat disease. And this is actually a major function of chemistry to this day. The pharmaceutical industry is one of the major employers of at least biochemists and of definitely several other types of chemists. Now, taking this together, we've also got other fields that are a little bit more specialized, but definitely interesting. The dyeing industry, that's not the, not talking morticians, but, people who make clothes colorful. That one had a huge impact on a lot of chemistry development, especially actually later on, once synthetic dyes become a thing. That really kicks in a lot of the early chemical companies in the 19th century. But of course, at that point, chemistry is a full-fledged thing. So backing it up a bit. There's another discipline that's now usually handled by engineers or thought of more as in the context of engineering, and that is metallurgy. And metallurgy is definitely a major area that lends a lot of its knowledge to chemistry. And we kind of, the chemistry of metals and the physics of metals, which is metallurgy, of course, helps us learn a lot about chemistry. And that, of course, is trying to make better, refine metals more, make better metals for better functions of whatever we're trying to do. Now, at this point, I should also point out, especially when we're talking about things like gunpowder from China, a lot of the metallurgy, one of the other practical applications for a lot of the sciences, chemistry and physics definitely, is that of warfare. Unfortunately, that's a kind of a common thread through human history. There's a quote by Hiram Maxim of the Maxim gun fame. He was an inventor, absolutely prolific during the 19th century, and the quote is that in 1882, I was in Vienna, where I met an American whom I had known in the States. He said, "Hang your chemistry and electricity. If you want to make a pile of money, invent something that will enable these Europeans to cut each other's throat with greater ferocity." Yeah, not just Europeans, people in general. Unfortunately, war has, as old as humanity, conflict, does occur. And a lot of the sciences have been put to finding better ways to defend oneself and or attack one's foes. If you look at modern scientific funding, by far the major one, at least in the United States, is Department of Defense. Coming in second would be things like National Institutes of Health. So, curing disease as well as conflict. Of course, other practical developments, definitely made the history. Not the last one to develop, but the one that's kind of the hardest to formulate into exactly what it is physics. Physics really starts out as natural philosophy and starts borrowing and starts coalescing around other fields. Astronomy being by far one of the major components. Understanding, okay, I see the points in the light, they're moving. What are they doing? This is a major field of physics. Also, back to that whole Maxim's quote, understanding the path of projectiles fired from catapults, cannons, and the like. What are they doing? How do I predict where my cannonball is going to go so I can predict it right into the other guy's castle? Kind of scenario. Absolutely critical for developing physics. Also, though, we have things such as optics. Understanding the properties of light, understanding how that works so you can make better telescopes, better glasses. These things are useful, as well as understanding the properties of fluids and lots of what we would now call engineering. And physics and engineering are definitely intimately linked because the physics is understanding the core of what a lot of engineering is then going to apply and go out and actually do useful stuff with. You can't make useful stuff if you don't know what's going on, so you understand what's going on, and then you make the useful stuff. And typically, kind of that physical realm, that's what we quite often call physics. So with that, those are kind of the three areas that I'm going to be covering in this particular lecture series. That's a very brief overview. Honestly, if you want a better overview, I strongly, profoundly recommend Crash Course History of Science. I'll put the link in the description. Complexly has done an absolutely wonderful job with that series. They go through a lot of the content. A lot of content I'm going to cover. They're going to cover, but just from a different angle. It does a very nice job. Strongly recommend everyone take a gander at that. Much higher production value. They have a staff and a budget and writers and a better camera and everything. So yeah, check them out. Have a wonderful day, and I'll see you in the next video.